Hi guys, welcome to our first episode of Chem tutorial in 2021. So hopefully everyone has had a good break and have been learning some chemistry in class. Unfortunately, when I'm recording this, we are in the middle of another lockdown. That's why that's the whole reason why I started doing YouTube, because I got sick and tired of doing online learning. So I thought it would be easier for me to record these online, and so not just benefiting people in my class, people in my school, and then people in the country could, because that's the sort of mentality I normally have. If I'm already doing it, might as well make it spread so more people can make the most out of it. Okay, so one thing I didn't do last year was I didn't do any internal standards for level 2 and level 3 chemistry, so I'm aiming to do all of those this year as well as finding a bit of time throughout the year just to do those external topics, but concept by concept, and then going into them a little bit deeper. So obviously for level 1 science as well. Okay, so if you are new to the channel, so please like and subscribe, just to keep up with all the new things that I post. And you probably notice I've release a whole lot of podcasts online, so you can check those out, and every now and then I chuck some gaming stuff on there because that's what I do in my spare time. Okay, so today we are doing some oxidation numbers. So this is a redox internal, and this particular video would apply to anyone that's level 2 or level 3 and doing chemistry, because redox, it is one of the really popular internals, and I'm pretty sure all the schools that offer chemistry do redox. And oxidation numbers is something that all year 12s should be able to do, and all year 13 should be able to do, because it's the absolute basic of redox chemistry. And just give you a bit of background on redox before we go into this. Redox is actually one of the most important reactions in our everyday life. You just don't realize it. Any device that you have right now, any batteries that you use in your houses, those are all designed and they work because of redox. Okay, so it's actually a very, very interesting internal. Okay, so without further ado, that was a very long introduction, I apologize, but let's get into today's video. So we're just going to go through oxidation numbers. Now bear in mind that this is only for high school level. Sometimes there are things that when going to university and you're like, wait, you taught me these rules but it doesn't work, but because this is only for high schools. Okay, so again, applies for level 2 and level 3, so let's get into it. So these are the 5 rules I kind of summarized. Now it does, if you look at different textbooks, or it depends on who your teachers are, the wording is a little bit different, but then the rules are pretty much fundamentally the same. Okay, so if you look at rule number 1, I haven't used the tablet for a very long time, so let's get used to it. So for all elements, so when you have any element that is just hanging out by itself, for example like S8, for example Fe, for example, just think of any element like nitrogen, even oxygen, even hydrogen, just any element that's on their own, the oxidation number is 0. Okay, so I tend to write the number 0 just above them, just to indicate what the oxidation number is. And the oxidation number, it tells you what state it is in terms of its oxidation state, and then you can use that to sort of determine, all right, so if I have this particular state of this element, could it be, and then you can sort of figure out if it's going to be oxidized or reduced. Okay, because redox reactions works, you have to have an oxidation reaction and you have to have the reduction reaction. Okay, so for all elements it is 0. Okay, so this rule trumps all the other ones, like especially this is why I put it up as rule number 1 above 2 and 3, because a lot of people go, but you told me hydrogen is always +1, but when I have H2, shouldn't that H be having shouldn't that have a positive 1 oxidation number? Well, no, because as an element, the oxidation number, if it's an element just hanging out on its own, nothing else is in there, the oxidation number is 0. Okay, but in all the other cases in NCEA level 2 and level 3 chemistry, you have H1 H being +1. Okay, so do remember that, very, very important. And oxygen is always -2. Now there are a few exceptions. So with hydrogen, again, I highlighted here, when you have H2, the oxidation number is just 0. Now when you're bonding with the metal, the oxidation number is actually -1, but you don't get any one of those in level 2 or level 3 NCEA chemistry, at least. If you do IB or Cambridge, that's another story. Okay, so -1 if you're bonding with the metal, but you don't need to know that necessarily. So oxygen is always -2. So unless the other example on the other thing I didn't mention is here, unless you're bonding it in O2, the O2, because it's an element, the oxidation number is 0. But when in H2, any other cases, oxygen is -2, except in H2O2, that's when it's -1. Okay, so let me put that into some practice. Like say, for example, I'm just going to scribble all of this. So if you're new to the channel, you may not get used to this, because a lot of the things I talk about when I record is spontaneous. So I just any examples I think of, I just scribble. So just bear with me. So let's say if I have H2SO4. Okay, so sulfuric acid, what's the oxidation number of the elements? So this is where you need to start to train yourself just to implement these rules. No one's going to ask you to memorize these rules and write them down. Once you've done so many of these, you'll know them by heart. Let's say for H2SO4, hydrogen, by rule number 2, the oxidation number is +1. The oxidation number of oxygen is always -2. Okay, and then we look at rule number 4, number 5, and then we can look at what that means. But this is what you do. I say to my students every time, I say, if you see HCl, don't even think. You see hydrogen bonding to a different element, +1. Let's say if you have HNO3, there's no thinking process involved really. H is +1, always -2. And then you may go, but there's a 3, there's a 3 there, there's a 4 there, there's a 2 there. Does that make any difference? Of course it does in terms of the big picture, but when we're talking about the oxidation number, we are only talking about an individual element's oxidation number. Okay, so we'll get to that when we do a little bit, when we go through all the rules. All right, rule number 4, the oxidation number of what we call a monoatomic ion is the same as the charge. So this should be quite straightforward to understand. So mono means 1. So think of the, English is my second language, so when I learned monoatomic, I just think of monopoly. Monopoly means 1, so monoatomic, that means there's only one atom in the ion. Like say, for example, you have Mg2 plus, I have what else is here? I have Al3 plus, I have Br minus. So the oxidation number of these different ions is the same as the charge. Okay, so that's not very difficult. You sure can remember that. Now, number 5, this is where we'll put it all together. The overall oxidation number of a molecule and compound. Now, sometimes different texts will break it down to 2 separate rules. I just want you to remember the overall oxidation number is the same as its overall charge. Now, what does that mean? Now, this rule on its own is actually not that useful, because you will never, I'll get to that a bit later towards the end of the video, you don't compare the overall oxidation number at all. That will be very, very incorrect. If you do that, there's a straight cross and you're not going to get any tick out of it. But how do we use this rule number 5? Rule number 5, you need to use it in conjunction with all other rules that we talked about. Let's look at H2SO4. This is a good one. Let's say I want to look at the oxidation numbers. Okay, so what you need to do, you need to identify the oxidation numbers of all of these elements. Now, most of the time, it's not the hydrogen or the oxidation or the oxygen's oxidation number will change, because the with most of the redox reactions, the H and O's don't do much unless they are the key species. Okay, so most of the time they remain unchanged. It's normally the unique, what I tend to call the unique element, which is the one that's not hydrogen or oxygen, that have a different oxidation number change. Okay, so how do we know if it's a redox reaction? If a specific element, the oxidation number changes. Okay, so if we look at this, what's the oxidation number of, let's do a different pen. So rule number 2, H is always +1, rule number 3, always -2. Now something, and this is when you just need to substitute numbers in. You need to understand there are 2 hydrogens and each one of them is +1, so it's +1 times 2 plus sulfur. I don't know what sulfur is because that's not part of the rule. I know O is 1 and 1 O is -2, and there are 4 oxygens, so it's 4 times -2. Now what does that equal? That equals the overall charge, and this is the thing I was highlighting before. It equals to the overall charge. Now where do you look for the overall charge? You look at the top right hand side corner, and you're probably wondering, why am I not highlighting anything? Well, because nothing there. When there's nothing there, that's actually really important information. In this case, the overall charge is nothing, is 0. So the everything added together is going to equal to 0. So if you have an ion, then the overall charge is going to be like a +1, -2, whatever, and then the overall oxidation number, when you add up all of these numbers together, is going to be the same to that number. So now it's just simple algebra. So +2 plus the sulfur, it's not 5, minus 8 equals 0. That means sulfur, the oxidation number of sulfur is +6. Okay, so now feel free to take a screenshot of these rules, but I'm gonna need to do more examples now. Okay, so if I have H2SO4, if I have H2SO4 turning into SO2 as a reaction, and you go, wait, is this a redox reaction? How would I know this? You look at the oxidation number. So as we did, this is +1. The hydrogen is +1, the O is -2, the H is +6. Now, if you look at this one, the O is again -2. The sulfur, I don't know, so we can use all the rules that we have got. So sulfur, I don't know the oxidation number of sulfur. Each oxygen is -2. There are 2 oxygens altogether. That means the overall oxidation, again, is the same as the overall charge, which is nothing. So that equals 0. So S minus 4 equals 0. So S, it must be +4. So this sulfur has an oxidation number of +4. This sulfur has an oxidation number of +6. When you are going from +6 to +4, the oxidation number has decreased. And when the oxidation number is decreased, that means you have a reduction reaction. And this is where I kind of tell people, there's so many different ways to tell people to remember it, but with the reduction reaction, your number is being reduced. So it's reduction, so that hopefully that makes sense. Okay, so I'll just go through a few difficult ones, and then we'll wrap up this video, because I just want to keep this short and sweet. Now, the hardest ones that the year 12s and 13s complain about is this one. It's MnO4 minus and Cr2O72 plus. And I'll do the easy ones really quick as well, because if you can do these, you can do anything. Okay, so let's look at MnO4 minus. MnO4 minus turns into Mn2 plus. So we know the oxidation number of oxygen is -2. We know, if you look at the Mn2 plus, can you see straight away this is a monoatomic ion? It's just an ion on its own, so the oxidation number is the same as the charge. Now, I don't know this manganese's oxidation number, so I need to apply all the rules I've learned to go through this. It's an airplane just flying over my house. So let's go through this. So the Mn, I don't know the oxidation number. I know each oxygen is -2. There are 4 oxygens in there, so that's -2 times 4. And what does that equal? That equals to the top right hand side corner, which is going to be -1. So this whole thing combined together is -1. So as you can see, Mn minus A equals -1. Therefore, Mn must be +7. So this is +7. So you are going from +7 to +2. Okay, so the oxidation number of Mn in MnO4 minus decreases, excuse my handwriting, from +7 to +2 in Mn2 plus. Therefore, it's a reduction reaction. Okay, now please, now I do want to mention this because sometimes you go, don't think of elephant, don't think of an elephant, and then people think about an elephant. Now I hate to point out the mistakes that people make, then you actually make the mistakes in your internals. But when you actually look at this, and this is so common, like if you're someone making this mistake and you think that you're so stupid or something, don't feel that way, because every year I see so many kids thinking this way, because this is what they do. They just go, oh, look at that, that's -2. That's +2, so the oxidation number has increased, therefore it's oxidation. And then if you write this in your internal, guys, this is going to be very, very wrong, and I'm pretty sure your teacher, well, will be very disappointed, and yourself will be very disappointed as well, because this is not the correct way. You have to compare the oxidation number of the same element. Okay, so you can't use the overall oxidation number because it doesn't tell you how much the element has oxidized or not. So it's normally the whole species, the whole compound do something, but most of the time it's actually just because of that singular element that do stuff. Okay, so let's do, so that was pretty hard. Now Cl2O72 minus, every year that we have kids in my school that don't get excellence is because of this particular combination. So again, but not because of the oxidation number, it's because of the balancing half equation, which we'll talk about in the next video. All right, so Cl2O72 minus to Cl3 plus. So again, this has an oxidation number +3. Hopefully I don't need to hopefully I don't need to explain that anymore because it's the same charge. And then what about this one? The Cr, I don't know. Oxygen, each oxygen is -2. And then, that looks quite complicated, and this is where you just need to write it out. I don't know the oxidation number chromium, but I know there are 2 of them. If you wondered where that 2 comes from, there are 2 of them. Now, each oxygen is -2, and there are 7. Therefore, multiply them together. And what does the overall oxidation number equal? Equals to the charge, which is -2. So 2 times Cr, -14 equals -2. So 2 times Cr equals 12. Cr equals +6. So this is +6. So when you're going from +6 to +3, this is a reduction reaction because the oxidation number of Cr in Cr2O72 minus has decreased from +6 to +3 in Cr3 plus. So these are the hardest ones. Okay, so just really quick with some really easy ones. If you have like say Cl2 to Cl minus, if you have like something like Fe to Fe2 plus, then if you get these in internal, then you're quite lucky because these ones are really easy. Like so Cl2, this is an element, this is 0. Cl minus, this is monoatomic ion. So you're going from 0 to -1. That's a reduction reaction. If you're going from Fe is 0 because it's an element. Fe2 plus is +2. So you're going from 0 to +2. That's why it's an oxidation. Okay, so just one last thing before I do this, just to make your life a little bit easier. Now you do need to be quite good at your table binds for this to work. Like say if I've seen people get confused with MgNO32, this is probably not, it's not gonna do redox too much with the NO32 in it, because that's a spectate ion. But for the sake of the video, I would like to show you how to do oxidation numbers. So you can, this is where people get a little bit confused. They go, all right, I know the oxidation number of O, but what the heck is Mg and what the heck is N? You never told me this. They're not part of the rules. I'm stuck. I don't know what to do. There are 2 things that I don't know about. How am I supposed to figure out what they are? Well, if you're good at your table binds, then that's why we have a quite rigid prerequisite system. It makes sense. If you can't do NCEA level 1 acids and bases, you shouldn't really be doing level 2 and level 3 chemistry because you're just gonna find it so difficult. So hopefully you can see that if I break the Mg2 plus MgNO32 to the ions, can you see these are the 2 ions that I'm getting? And then people ask, what is the 2 there? Well, the 2 is to balance the charge because that's 2 plus, that's 1 minus. All right, so if you're still getting confused, go watch my acids and bases videos in NCEA level 1. So as you can see, when you get to this stage, can you see how easy that is? Mg2 plus, that's a monoatomic ion, so that oxidation number just +2. And then if you look at the NO3 minus, you can just do that separately. O is -2, nitrogen I don't know, so nitrogen plus -2 times 3 equals to the overall charge, which is -1, so n must be +5. So that must be +5, +2, and there you go. And that's how you get it done. Okay, seems very simple. We don't give you the table of ions in level 2 chemistry because the more you learn, you know that the nitrate ions is actually spectator, it doesn't do anything, so it is just a magnesium that do stuff. Okay, but you know, for the sake of this video, I think that will be quite helpful. Okay, so hopefully this video has been I didn't expect to spend 20 minutes on this, but you know, it is absolutely crucial that you can do oxidation numbers, because if you can't do oxidation numbers, you can't do redox. Okay, so hopefully this video has been helpful. So I'm back, you know, to do some chem stuff throughout the year, so stay tuned, you know, and some level 1 science stuff as well if you have younger siblings or family friends that need help. So stay tuned, subscribe, like the videos, turn the little notification thing on, and hopefully the video helped you today. Okay, so stay tuned guys, and I'll see you guys next time. Bye bye.